All right, hello and welcome. In this video, we're going to look at how to calculate the resonant frequency in a series RLC circuit. So note that if you're working with a parallel RLC circuit, that's going to be a different calculation. You're going to have a little bit more to account for here. But with this one, we're just going to go after our FR. We know that the FR, the resonant frequency, happens when the interaction from the capacitor and the inductor match each other, and we end up with a net zero, right? Our X total ends up not having a phase at all. And so that's what we want from this. And that only happens at one frequency per circuit. So it depends on the size of each of those capacitors and inductors on where that frequency is going to land. Right? So we'll say that FR is equal to 1 over 2 pi times the square root of our inductor total and our capacitor total. Right? And those are in farads and henries. And so we're going to leave them just as is and plug this directly into our Desmos over here. So we'll say of 1 over 2 pi times the square root of our inductor, which is 0.001, that's our Henry's value, multiplied by our really small other value, so 0.001 times 10 to the negative, and that's in micro, so we'll put a 6 there. And that is our resonance frequency. So we'll plug that in. We'll say FR is equal to 159,155, and that's in hertz. That's a pretty big number, so we can move that over and say that if we moved it back 1, 2, 3 spots there, we can get a new value. We say that our FR is equal to 159.2, and that is kilohertz now. All right, let us know if you have any other questions.